Hey everyone, and welcome to Building SaaS on AWS. My name is Gunnar Grosch, developer advocate here at AWS. And if you are building or planning to build a SaaS product, this is the show for you. Every other week, I bring on SaaS experts to deep dive into SaaS-specific topics and let you, our viewers, learn more about building SaaS on AWS. And this week is no different. I'm joined now by Mike from PlanetScale and our old friend Bill from AWS SaaS Factory. Welcome to the show, both of you.
Thanks, Gunnar.
So we always do the quick round of introductions. So Mike, tell people a bit about yourself.
I'm Mike Coutermarsh. I'm based out of the Philadelphia area. I'm a software engineer for quite a long time now. I work at PlanetScale, and I'm very excited that you called me a SaaS expert this morning.
Well, glad to have you with us, Mike. And let's see by the end of the hour if I still call you a SaaS expert. I think I will.
It's on. It's on.
Yeah. So, Bill, people know you maybe, but let's do the intro anyway.
That's great. Well, if we do have any new viewers, hey, everybody. My name is Bill Tarr. I'm a partner solutions architect with the AWS SaaS Factory. I'm based out of San Diego, so we have a pretty good geographic spread today. I've been with SaaS Factory for about 2.5 years, and the SaaS Factory provides strategic enablement on SaaS. We lead a community of AWS builders and community builders like our AWS competency partners who provide expertise on how to build SaaS on AWS. And that's what we're here to talk about today, Gunnar. So let's go.
Let's go. Yeah, and we aim to make this show highly interactive. So if you have any questions, any comments, just pop them in the chat and we'll do our best to answer them throughout this hour. And as I said, every other week when we do this show, we have specific topics to dive deep on. And this time, of course, we're going to dive deep into PlanetScale and what they are building on AWS. And in the title of the show, we call PlanetScale a DevOps database. So, Mike, is your product aimed at DevOps engineers?
Yeah, it's a great question. So we talk to a lot of companies about their databases, businesses, like how are their developers using databases, deploying schema changes, building software. And the biggest thing we hear about is difficulty around change of the database. So if you think about, I think back to when I first started as a developer. I remember on one of those first jobs, we had like this really great DevOps setup, right? We had CI/CD, you could deploy 10 times a day. Like it was really a dream for developers, except for one thing. Anytime you needed to change the database, it was incredibly frightening because especially as a junior developer, you come in, you don't have complete expertise about this system. And so many things can go wrong, right? So you could, I remember having to memorize this list of things that were safe and not safe to do, right? So like I'm adding a new column to a table that has a default value. Well, that could lock the table in production. So maybe while I'm deploying that, our users are no longer able to write the table and I'm bringing the application down. So there's a lot of fear around this. And what we found is like most companies, like even the best ones who they've set up tooling around this, they have like an expert team who knows about the database and they're reviewing every change. Like that's how they make things go out safely. So right now for most companies, like the best of the best, it's still pretty centralized and there's a process that's different than your code. So what we're doing is our company has a lot of experience at building databases at the highest level of scale. And then also we've worked in large engineering organizations, small, and we've like seen that experience of what it's like to deploy schema changes. And we've been taking all of that knowledge and building solutions for it so that we can make it match very similar to like what a normal application developer's flow is, right? Like that standard, I'm building a feature, I'm gonna branch something, I'm gonna make changes, I'm gonna run tests. And then I get a code review and I review it. And I can just do this all myself without bringing in another team. So that's really kind of the DevOps for databases. It's you can do this, your developers are independent, but they can also do it safely and you can trust them to not take down production.
Oh, that's great. And I think looking at your website, I think your tagline says that the MySQL-compatible serverless database platform. But you also position your solution as more than just managed MySQL. So what other value are you adding beyond just that database offering?
Yeah, so there's really two things. The first one we just talked about, the developer experience. People come use PlanetScale and it's a whole new experience for them and they love it. The second is Vitess. So Vitess is probably one of the oldest Golang projects. It started inside of Google. It's a really fun story. I'll give sort of the brief version of it. So Google's running MySQL and they have these database scaling problems, of course, because YouTube is getting tons of traffic. So they start building tools around MySQL to solve these issues. So first thing they do is every database has issues with connection pooling, right? Like people run out of connections. That's a challenge. So they built a tool for that and solve that issue. Another one was, say you have 100,000 people all hit the same YouTube page at once, and it's loading that comment section. That's the same query across all of these people's browsers, and it could be really rough on MySQL. So they built this thing into Vitess where it will see that it's getting all of those queries at once, that same query. It's going to hit MySQL once, but return the result to all of those people, really saving your database. So they continue to build tools on that around MySQL, and eventually this turned into the project that we now know as Vitess. Probably the most exciting part about it is just like the raw ability to scale is what people see Vitess and they get really interested in. The main thing that lets you do that is sharding. So for most businesses, when they're scaling up, you sort of start out, you kind of have a small database, and that initial strategy we call vertical scaling, right? And that's throwing money at the problem. You add more CPU, you add more RAM. It's just like a bigger and bigger box. That works really well for quite a while until you can't buy a bigger box, right? And now you're in trouble. So there's alternatives to this, right? People will split a table into another database. They'll do things like spin up a bunch of replicas and send all the read workload just to those replicas. What we found works really well is sharding. And sharding simply is for your database, it's essentially horizontal scaling. So instead of having a table on a single machine, you can have that table across 100 machines. And then based on the query, it knows which machine to direct that query to. And having Vitess like built in and available to you gives people a lot of comfort because they're like, hey, my business is small today and like I don't need sharding, but I have these grand plans. Like we're going to be YouTube one day, or we don't know what kind of data we want or how much scale we're going to have, but we want it to be easy to scale out. So this really just gives you the opportunity and option later on when you do hit those challenges to go in that horizontal scaling direction really easily.
Yeah. Let me jump in on that real quick, Gunnar, because I think this is an important point. And one of the things I'd want to emphasize for our audience as they're thinking about PlanetScale is while PlanetScale is themselves a SaaS ISV, they're building SaaS for their customers. This is also a really friendly solution for their SaaS customers. So if you're a SaaS solution, one of your primary concerns is scalability. SaaS is a growth model. So as a SaaS builder, I'm looking for solutions that allow me to scale infinitely. And the database part's a very challenging part. If you're using a traditional database, how you scale those databases and grow over time is a challenge almost every SaaS provider I talk to runs into. So this is one of the interesting aspects as we focus on how PlanetScale built their solution, but also how their customers can use their solutions to make their SaaS solutions more successful as well. It's one of the things I think that really sets PlanetScale apart.
And Mike, do customers see or notice, or do they even have to care about that it uses Vitess? Or is that just like a fully managed Vitess solution part of it?
Yeah, so it really matters at what level of scale you are. For most people who are starting out and they're not looking at things like sharding, it's pretty much transparent. It's compatible with MySQL. Even our own development team, we run our local application against stock MySQL, and then we also test it against PlanetScale. And like doing that ourselves just really hones in, like they need to be one-to-one compatible so that you're not noticing. And then as people scale up, it gets a little more complicated when you add in sharding. At that point, we have our team work with people just to make sure they set it up correctly. So like a recent example is we did this internally. Like we had an internal team who was building a new product, and they're like, well, it could be a lot of data, but we're not really sure until we ship this thing and it's in production. So we designed the tables right away to be compatible with sharding. Basically, to do that, you just have to have a key to segment the data. And in our case, it's very easy. We can segment per database, right? So certain databases are in this shard, certain are on another. So we launched this product with just 4 shards, and it ended up having way more data than we expected, but we were very comfortable, right? At any moment, if we sort of hit that tipping point, we can reshard and just add more.
So I think maybe you've already covered some of this, but maybe to hit the nail on the head, what differentiates PlanetScale today?
Oh, so one thing I would say, this is the thing that was most exciting to me when starting here, is our ability to have very safe schema changes. Just because I've been burned by this so many times, sort of big companies and small, like if you make a mistake with a schema change, you're taking down a website, and especially if you work at somewhere that has a lot of traffic, it's a lot of pressure. So our team had experience with all this tooling, which is known as online schema changes. So generally what most people do is when you want to change the schema, you directly run DDL against the database. So this is like your alter, your create drop commands. Not all of those are safe to run against a production workload. So there's this tooling around it. This is what like the big companies use. Like you go into any big company, they have this, they have a process, there's a team that does it. And these tools that you have do your schema migration in a non-blocking or online way. And the way it works is really cool. So when we do a schema migration through PlanetScale, what's actually happening is we don't run that DDL against your primary, because that's dangerous. In fact, we actually block it, because in our opinion, you shouldn't be doing that. It is dangerous, and we don't want customers to be accidentally taking themselves down. Instead, they can branch, go through that sort of DevOps workflow. And then when they deploy the schema change, what we do is we actually bring up 2 copies of the table. So you have your original table, and then we bring up a direct copy of that table. And we call this the ghost table. That ghost table then has that DDL applied to it. And it sort of, as this is going on, like your app is active, like things are streaming in. Like we're writing to both of these tables and keeping them in sync. And at that point where both are in sync and ready to go, we just swap them really quickly. So your production data was going to old table, it's now the new. And that table's ready to go. So you don't have to worry about downtime. So that's really, it's a thing a lot of people don't know about, but we just built it into the product. So you're forced to do what we say is really the best practice and what we've learned at high scale. This is the best thing to do.
So no endpoint changes for the customer or anything like that. That's when doing that swap, it just happens in the platform, transparent for the customer.
Yep, it just happens. You're connected, you're running queries, we swap, you're still running queries, and there were just no issues.
Yeah. I think there's an important keyword when we talk to SaaS providers, which is zero downtime deployments, which is really difficult to achieve in the real world, right? Anytime you have a shared SaaS platform where hundreds of tenants may be using your application at any given time, you don't have maintenance windows anymore. You can't simply say, hey guys, we're going to take this down for an hour and we're going to be back. Instead, it's got to be seamless to them. Your application has to appear that it's always up. And this is an interesting take on how to do DDL changes and achieve zero downtime, which is really, when we talk to SaaS customers, that's one of their biggest blockers usually to getting to a solid DevOps story and getting to zero downtime.
And yeah, in my 20 plus years in this industry, I can attest to that schema changes are scary for sure. But one thing that's perhaps even more scary is schema changes rollbacks. So how have you solved that, Mike? Have you solved that?
Yes. So earlier this year, we released a product called PlanetScale Rewind. And It's absolutely mind-blowing. I couldn't really believe that we were able to get this to work. My coworkers are very bright. So the way this works, the way Rewind works, is typically if you need to roll back a schema change, you just deployed it, your application's erroring, maybe you're getting paged, right? It's like a high pressure moment. Things have gone wrong. Your options are generally, you can apply DDL that reverts it, and like maybe that will fix it. Or you're going to roll forward with your application code. So you're quickly rolling out a change, and you better hope you can deploy quick because you're in trouble right now, right? And another that I've seen, if it's really bad, sometimes people will stop everything, restore from a backup, and then move forward, right? So you're down for hours. I was in one situation once where we had to do that, but it was also for a company that was doing financial transactions. So you can imagine you have to roll back, but then we've also been continually writing very important data to that database. It was days of DBAs going through because you can't lose that data, and just replaying to make sure it's there. So PlanetScale Rewind, what it does is, so we talked before about how we have those two tables and then they swap. So what we do is each time you do a schema migration, for 30 minutes after the schema migration, we're actually keeping that old table around so you can swap back. Now that's cool in and of itself, but like the really nice part is the whole time while this is running, we're actually streaming all of the inserts to both of these tables. So say you dropped a column, for example, but since then you've had 5 customers pay you, and those payment records are now in the database. When you revert back and swap those tables back, those records will still be there because we've been streaming them to both the whole time.
Nice. That's cool. That's really cool. So I know that people love seeing our faces on screen. For sure, we can probably be in this way for the rest of the hour. But what I know that they love even more is seeing architecture diagram. So I think we want to dive into that now, Mike. So what do we see on screen now, Mike?
All right, so this is a pretty high level diagram of how PlanetScale works. And really like the two things to know, and as a SaaS business, sort of all infrastructure providers generally set up in this configuration. And I'm sure Bill can talk a lot about this. You have your control plane, which is here. And the definition of the control plane is really, this is everything that the user is going to work with. So this is the dashboard, the API, the CLI, any way that you're sort of working with your infrastructure, it all goes to the control plane. And then on the other side of that, you have the data plane. So this is where the actual infrastructure lives. And we have these separated from each other. So say this is your database. Like here, you can see we have a database. This is a test cluster that's spread across 3 availability zones in the data plane. And let's see, I'm just going to make this bigger. Oh, that seems to be making it smaller.
Yeah. Browser-based tools. There you go.
I promise I'm good at computers. All right. Is that better?
That's a little better. Yeah.
Okay. Yeah. So the really interesting thing that we set up is we have this very strict relationship between our control plane and data plane. It's really a single path between the two. It's all through protobufs. So it's typed. We're very strict about what can reach into the data plane and make changes. And we have this sort of reconciliation process. So each time someone goes to PlanetScale and say creates a database, the control plane is making a record like, hey, I made this database. It's going to be in this region. It has these attributes about it. And then it says, hey, data plane, which is backed by Kubernetes, make it real. And then the data plane brings up those resources and then goes back to the control plane, hey, it's ready. And then the control plane just has a bunch of things going on. Like once it's ready, we're alerting the user, hey, your database is here. We're sending out WebSockets. So the website updates, you'll see notices on the CLI. And then that's just that relationship. But it really, the key part for I think people to remember is it just all goes through a single, very strict pathway between the two.
Yeah, and I'd sort of just chime in on the concept of a control plane as general in a SaaS application. This is really one of the differentiators we see between what we call SaaS and what we say is kind of SaaS, or maybe not exactly SaaS, is the presence of a control plane. Because as you can imagine, if you sort of take this model and you think about it at scale, these data planes could be in the tens or hundreds or even thousands of tenants who each have their individual implementation. If you don't have an application, and you might be encouraged to think about it as two separate applications, a separate application that actually controls and provides a single pane of glass for viewing all of these individual tenants' data planes, it's going to be almost impossible to manage this application at scale. So the ability to handle, say, the identity, how are we going to manage the identity of all of these different users for all of these different tenants? And how are you going to constrain that API access? How are we going to emit metrics back up from these data planes? You need that single location. And we can call that the control plane in SaaS. There's a lot of different flavors of a control plane. It's probably the most unique component of every SaaS provider's architecture. But nonetheless, this is something that all SaaS providers who I've seen that are successful have some version of this, and they manage this. This is really where their day-to-day for everyone who's operating the SaaS application. This is where they live on a day-to-day basis. So it's an important part of the architecture to call out.
So next then, how do you keep operational awareness of all of these clusters then in this data plane?
Oh yeah, so something that's been really successful for us is in the data plane, we have set up instances of Thanos, which for people who haven't heard of it before, Thanos is an open source project, and it's basically Prometheus as a service that you can deploy, and it keeps all of your sort of information in memory, but then also backed by S3. So what we're doing all the time is from the data plane, we're emitting metrics from everyone's database. They go to our Thanos cluster. And then we have our control plane. So if like you go use our application and you go to the front end, you'll see these graphs that are explaining like, this is your QPS. This is how many rows are being read. This is how much storage you have. We have a single point in our control plane, and that's all in Thanos. So we're reaching back to Thanos, grabbing that information that's constantly being emitted, and then that's how we display it to users.
Yeah, and this is another important point to follow up on. As we were talking about the control plane, one of the things we mentioned is this single pane of glass to provide to the people administering the application in PlanetScale, but then often in the cases like this to actually reflect back to the customers as well. Your tenants may very well want to understand the operation and how their individual environments are being used, how successful they are, the performance of those environments. So this is another common ingredient we've seen in the control plane, but really the implementation of this is down at the data plane, right? All of your code has to be instrumented in such a way that it can continually emit these metrics and emit them in a multi-tenant fashion. Like we have to always be able to go back and understand all of these metrics, all of the logs that we've emitted back up to our control plane. We have to be able to aggregate those and also de-aggregate those to potentially diagnose a significant issue, or in the cases like this, simply reflect those metrics back up to your tenant admins or your end tenant users.
Yeah, that brings up a really good point. So, something that I liked that we did that's been successful for us is anytime you create a resource in PlanetScale, so if you create a database or a branch, we create this ID system. So it gets assigned a random, it's like a 12-character string, and that's the ID. And everywhere in our system, everything gets tagged with that. So the Kubernetes pods are tagged by that. The metrics that go into Thanos are tagged by that. And that's the shared identifier across the control plane and data plane. So when we're querying for metrics, like we know we can use that identifier, and like that's how we're going to pull out information.
Makes a lot of sense, yeah.
So we got a very interesting question in the chat related to what we talked about before with schema, well, reverting the schema. So It's from Nigam the Best, and the question is, how do you handle the insert that are not compatible due to schema changes?
Yeah, it's a good question. You're then in a pretty tough situation. So if you you change your schema and your application is now failing to insert, at that point you really have two options, right? You can revert immediately to the old schema, and then the inserts will continue to work, right? Because you're now at that schema that was working, or you need to go in and change your application code so that it will work with the new schema. Generally, I'd recommend, since it's faster and you have rewind at PlanetScale, just rewind that thing quickly and then update your code. So after the next time you try this change, it will work.
All right. There's another question. Are there rollback mechanisms to changes that might break the database?
Ooh, we've done a lot of work around this. So rewind will not always work. There are some cases where maybe you, so say you had a column that stores 200 characters of text, right? You do a schema migration and you've changed everything so it's now shorter. But now your application is still trying to insert data that is longer. If there's any case where going back will hurt the integrity of the data that has since been inserted, we're going to tell you in the dashboard, like, hey, you can't, and this is why, and we'll give you a message. So yeah, there's definitely cases where it doesn't work. We have a full doc site where we went through sort of our experience with sort of gaming out, like, hey, what could happen in this scenario, and this is what you can expect. So it's definitely a good thing to read through, just to sort of understand what you can and can't recover from.
So if you just joined us, this is Building SaaS on AWS. I'm Gunnar. Today I'm joined by Bill, who's usually in the chat for all of the episodes. Now he's actually on the camera. But I'm also joined by Mike, and we're talking about PlanetScale and their MySQL-compatible serverless database. Did I get that right, Mike? Sorry.
Perfection.
Just when you're drinking as well. So at this point in the episode, I think it's time to jump in and actually see PlanetScale at work as well. So let's spin up that demo, Mike. And
Great.
Keep the questions
Okay.
coming in the chat as well. It's great to see some chatter.
Yeah, if you see anything you're interested in, just call it out and we can talk about it some more. So this is the PlanetScale dashboard. When you come to PlanetScale and create a database, and I prepped one for us because you never know about the live demos. I created a database for us and I added some schema just so that we have something to work with. And my plan here is I'm going to show you how you can branch, make a schema change, and then we're going to deploy it. And then my plan is we'll probably do something dangerous that goes wrong, and then we can revert it. So like people can sort of see through that whole flow, which would be pretty fun. So the a really interesting thing about PlanetScale, generally when you have a database, you just have that one instance. But as developers, like we're really used to working in Git. You have your main branch, you branch off of it, you sort of do your work, and then you merge it back in. So same for PlanetScale. And let me jump to the CLI just to show you. So everything I'm showing you that's in the UI is we have parity in the CLI. So if you're a person who likes to just live in iTerm, that works for you. I'll kind of show both so you can get an idea. So I have this database, Mike Test Demo app, and I can connect to it. So I can open up a shell. I can just say pscale shell demo app main. And I'm specifying my org here. So here we go. So this is just your standard MySQL shell. I'm connected to main. And notice we have these little alert icons here. Remember before when I talked about you can't make schema changes on main? Like main's important, it's a production branch. This is indicating this is a production protected branch and you won't be able to make schema changes to it. So there's no like the CEO accidentally dropped users here, like we just protect you from that. So I set up an example table here. So we have organizations and little typo, select from organizations, and I have these 3 records, and I'm going to show you the schema. So the schema for organizations is pretty simple. It's just a demo. We have ID, login, and then role. Now, pay attention to role because that's the one we're going to mess with. Role is important here, and this sort of replicates if you had like a user being put in and they have a certain type of permission, right? Like you might be a user, admin, read-only, for example. I set the default here to be user. So every record that gets added to this table, it will be a user. And then you can see here, I added a couple who are admin and read-only. So there's my table. Now, if I go back, and I could do this by the CLI as well if I wanted, I'm going to create a new branch. And now, like something I want to call out here, it's all of this, and we've done this very intentionally, is this looks extremely simple. So it's our opinion that developers shouldn't have to worry about IOPS or knowing how much storage they need or RAM. We're figuring that out for you. So this is hidden, like all you're doing is selecting a region. I'm currently in the US East, so I'll use US East, but something we've seen developers do is, say I'm developing in your team, you have someone who's in Europe, they'll bring up a branch in Europe just so they benefit from the latency when they're doing the local dev. Yeah, so I'll create that branch there. While that's coming up, I'll show you a couple other things. So this database is interesting because I actually spread it across 2 regions. So we talked before about the data plane and control plane. The data plane is emitting to the control plane what regions are available. And we've recently released this in beta, is the ability to set up a read-only replica in another region, which is really interesting if you're doing things like, say you have a lot of customers in the US, but you also have a lot of customers in Germany. And the latency from Germany to US East, that's about 100 milliseconds, which when doing a bunch of queries, that adds up really quickly. So what you can do is bring up another region, and then all your read requests could go to that. And then you get that quick sort of 2-3 millisecond latency that everyone loves to have. So let's go check out this branch. So here's our branch. It's going to be exactly identical to our main branch. So I can connect to it. I need to dev. I can say, show tables, describe organizations, right? And we can see the schema. So what this did is it copied over the schema. The way we did it, it doesn't copy over data. On our team plan and above on PlanAScale, you can actually copy over the data, which is really useful if you want to test out sort of like a data migration or a performance change against real production data, but without affecting production. So what we're going to do here is, and hopefully there it is, I'm going to drop this column. So I dropped it. We'll go describe organizations, and it's gone. Wouldn't recommend doing this in real life, but it was fun demo. These things happen. These things happen. I've definitely dropped columns that I thought weren't needed, but they were. So I'm on this branch, and I'm going to say I dropped role because it's not needed. And then I create a deploy request. This is very similar to doing a pull request, right? So I had a branch, I made some changes, I'm opening up deploy requests, and then my team can review this. And this is like where we give this really nice UI around schema change reviews. So a bunch of things here. We're calling out, what are you doing here? Okay, 1 altered table. If you drop a table, it's bright red. We let you know. Down here, we show you the actual operations that are going to occur. We do this really crazy stuff where we're comparing the schemas. We figure out a diff, and then we we determine what the best DDL to run is to make that change. And if you're curious about that, you can click this. And this is exactly what we'll run, which looks quite familiar, but that was generated by PlanetScale based on the diff. We also have this nice call out, right? Like we're all about letting developers know when you might do something dangerous. So this one may result in data loss. We actually know like it's going to, right? That's sort of our plan. So like, okay, that's acceptable. And then another thing we really like is you can go into the schema change and it's just like your diff and Git, right? You can see that's what's going to change. So people can review this, they can approve it. And then once it's approved, you can do the deploy. So I'm going to deploy this now. And what this is doing is it's spinning up those online schema migration tools that we talked about earlier and submitting it to Vitesse. And then from there, Vitesse is, and this is happening right now, it's got those two tables. It's making the change to that new one and then swapping them. Because we have very little data, this happens super fast. In cases where, say you have, 100 gigabytes of data, it's going to take hours or it could take days, just depending on the activity of your database, because that's an intensive operation. And as it's going on, we do throttle any activity that's happening from the schema migration so that we're not affecting production traffic. Okay, so I did this change. Let's go back. And I'm going to connect to main again, right? Here's main. We'll do our select. Our role is gone. And if we try, right? So imagine your application has this query. Let's say, hey, Bill just signed up for an account. He wants to be an admin.
Yeah.
Erroring, right? Like that's just popping up in our Sentry and, someone's getting paged. But let's say our application sends this without a role, right? Okay, that works. Great. We expect that to work. We select. There's Bill with no role. So we were going, all right, I need to revert this, right? It's a disaster. I messed up real bad. Click Revert Changes. And this is going to tell Vitesse, hey, swap those tables back. So changes were successfully reverted. So we've swapped back. Hopefully our error has recovered. The incident command room in your Slack is happy with you. And if we go back here and I do that select again, role is back. Now, the cool part, which it's not immediately obvious, Bill has a role.
Yeah.
So remember how we set that default role here? There's a default value for user. That other table, we essentially executed this same query, but on that other table and then reverted back. So it's something very powerful where you have sort of a typical flow where you're trying to go back. You just don't have that available to you. That streaming of queries and keeping data up to date.
That's
yeah.
really
So once
cool.
that's done, we can delete our branch because we'd like to clean up just like a Git branch, and there it is. We can make our change again, but attempt to do it differently this time.
Very cool.
Well, that's really cool. Yeah, definitely. So you showed that you're using multiple AWS regions and that you are deployed in multiple AWS regions. So has that approach needed to change to manage data planes across different regions?
Yes. So showing this here, these are the regions that we have available. When we first started out, we had US East only, as sort of most people do. They pick a region and they start there. And in our control plane, it was literally like it was a hard coded string, like it's going to US East. And then we added Frankfurt, I believe. And then we hard coded Frankfurt. So we had that list of 2 regions. This works when you only have a small number of regions and things are very simple. But what we learned very quickly is we need to have a single source of truth that's in the data plane that's constantly emitting, okay, what regions do we have available? What's the capacity? Can we create more databases here? That way you don't have the manual process of going in, changing code, hard coding these strings. So what we did, we set up that source of truth in the data plane. It syncs every few minutes. And what that's doing is letting the control plane know what regions are available. And for any of these regions, if we don't have capacity, for example, it will get grayed out and it will show a little message. Also, say we have an incident in a single data plane, like maybe something went wrong. We can disable that data plane so new databases don't go there, but it's not affecting the reliability or the creation of any other region, which is really important to us. So like you can still create, but we've isolated that incident.
And you talked about earlier that you're using Vitesse, and that's a CNCF solution. So do you give back to the open source community? Maybe a leading question, but do you?
Yeah, this is one of my favorite parts. So the Vitesse core team are all employed by PlanetScale. And the thing that's really cool about it is, so all that stuff I just showed you, you would think that must be proprietary, right? Like who's going to share that with the world? But when we were building this, all of the building blocks for that are open source in Vitesse. Like you could go through in the pull requests and see my teammates adding the ability to do this revert or do the schema migrations and sort of making all of that much better. The thing that was surprising to me, like when we first started, was Vitesse, while running on the sort of the biggest workloads in the world, it was still running on a select number of applications. When we launched PlanetScale, we suddenly had tens of thousands of applications all using Vitesse. And you kind of know that thing where like building a business and application in software, you can do that, and that sounds simple. But then when you have a lot of customers, it's very different. So like we quickly learned from all of these different use cases and actually found bugs and edge cases in Vitesse. So it's like very interesting. The business exposed Vitesse to the world. We found the issues, and then we just pushed that back into an open source project. So everyone's benefiting. And then also these cool features we build. The building blocks are there. So if you wanted to do a rewind-ish flow and you run Vitesse, on-prem, for example, the pieces are there. You could do it.
Yeah. I think this is one of the hottest trends that we've seen with SaaS providers, a concept that some people call open core. You could call it a number of things, but this concept where rather than trying to create everything in a black box and saying, here's our SaaS solution, use it, accept that we did everything right, simply having an open source core to everything that you're doing and having that be available to customers really creates a level of trust with your customers to say, listen, hey, we're going to give this stuff to you if you want to use it. Our value add is on how we manage it. So we're going to give this back to the community. You guys can take a look at it, understand the best practices that are embedded in the code. You can go implement this yourself if you want a free version of it, or you can trust us to manage it for you and handle all of the scaling and the big things that involve a SaaS platform that you don't want to have your people dealing with on a day-to-day basis. And we're seeing this across the board. It's just a lot of interest. Universities, of course, and big enterprises where you have AppSec who has to review everything that they buy, find this to be a really nice value proposition for, I want to have someone manage this for me, but I've also got to understand how it works really well, or I can't accept that our users' data can be passed through it. So it's a really nice combination for a SaaS provider. I think it's a great feature for PlanetScale.
And moving on then moving back maybe to the more SaaS related questions of this. So we often talk about different deployment models and isolation models for different tiers and so on. Can you talk a bit about the different deployment models that PlanetScale has?
Yeah, so when you come to PlanetScale, you have two options. You can, if you come directly to PlanetScale or you come to us to the AWS marketplace and sign up and create a database, that's going to be using one of our shared tenancy model. So a shared cluster where you are using the same data plane as other customers. So any of these that you see here, when you create them, that's working with all of our customer base. When we launched this, we had a lot of demand from larger companies who are maybe more privacy sensitive, or they want more control over cost in their data. Maybe it needs to be in a specific region for them. This was very important. So we also have a single tenancy model, which can be set up through our sales team. We call that PlanetScale managed. And in that case, we are actually deploying everything. So you have the same control plane that everyone else has, all of these same features, except your data in the data plane is, let me bring that diagram back up. All of this is in your AWS account instead of our own. And you'll even see in the UI, instead of all of these options, you'll see your own region that is just for you.
Yeah. Another important trend that we see with SaaS providers, trying to meet your customers where they are. A lot of people want to use SaaS as a completely managed hands-off solution, and having that option and saying, "Hey, we'll manage everything for you guys. You can just hop onto our shared platform." Or for a lot of very compliance or security sensitive companies, or even companies who just have data gravity problems. They have so much data, they don't want it passing and forth between different accounts. For those type of customers, having multiple options for deployment, increasingly in the data and the analytics space, we're seeing providers have to provide more than just one deployment option so that they can meet their customers where they are and go both up and downstream in terms of approaching the marketplace and get to all of the customers that they could potentially reach.
And what you mentioned there, Mike, as well, with the different deployment models, the shared and the silo one, that means that customers can manage customizations to their services through that same SaaS control plane, no matter which model they go for.
Yeah, like we had talked about earlier, developer experience is really one of our main selling points that people love. So we'll have these large businesses come to us and start talking about wanting to have that single tenant database deployed in their own AWS account. And we find out, why they're here is they've had 20 of their developers have signed up previously using just sort of the free multi-tenant, and they went through the flow and they really loved it. And they thought, okay, I get to try this out. I really like the developer experience. But for it to work for my business, we really need it in our own AWS account. So it's been a great way to providing both of these. People get the experience and understand before they really go into commit on bringing it into a larger business.
Another thing that we often talk about on these shows is user and tenant identity. So how do you manage that in your control plane?
Yeah, so our control plane, there's 3 ways you can log in. You can do sort of the standard user email, password login. You can do OAuth with GitHub. And then we also have SSO available. So SSO going through whichever provider you use. We partner with WorkOS, who I'd highly recommend for anyone else who's implementing SSO in their product. It made it very simple for us. And so say, for example, we have a customer who's using SSO through Okta. We have features in there so that your Okta administrator can add someone to the PlanetScale app. As soon as they log in, they have access. They can set them to a certain team, so they're automatically synced to certain roles or synced to certain databases. So that identity management in enterprises is very important. And then we allow it to sync right into PlanetScale. So when you are making a request through the UI, API, CLI, any of those, we authenticate as your user. And then we have this whole policy layer inside the control plane. And what this policy layer does is it has a role assigned to each user. And based on your role, that's what you're allowed to access and do. Mm-hmm. So if you're in that organization, you have admin, you can create a database. If you don't have admin, you can't, but maybe you can look at it. And that policy layer is what drives everything and what resources you have access to.
And what does all of this mean for onboarding then? Does it make it complex?
So if you're coming into the shared model and you can sign up and have a database created in 10 seconds. It's very simple. For people who are doing PlanScale managed, it's a little more work, but what we found works really well for us is we've just set up a docs website and we just make it very clear. Like if you're signing up for PlanScale managed, this is the information we need from you. This is how we're going to be working within your AWS account. These are the permissions we're using. Like this is the boundaries of what we're going to do, but also these are the steps that you need to take to set up. Same for SSO. We have UI where people can sort of, generally what happens, they'll have someone on their security team sort of go through. We'll send them a link. They just go through and set it up. But for the most part, like making that as painless as possible just involves iterating, documenting, and trying to just give customers as much step by step that they can do on their own.
Yeah. I just to chime in, when we talk to SaaS providers about onboarding, we're trying to achieve that frictionless onboarding story, right? As soon as you decide you want to start consuming PlanetScale, you want to reduce that time to attaining value from the product you just purchased down to as low a denominator as you can. And in the case of a shared solution, that's relatively straightforward, right? You click a button, you buy it, you start using it if it's entirely in a browser. For enterprises, that frictionless onboarding doesn't necessarily mean there's no manual steps. If you're going to federate with somebody's identity store, like Microsoft Active Directory or whatever else, there's going to be some steps people have to do. You're going to have involvement for their team. And if you're deploying things into their account, you're really going to have some involvement from their team. But still trying to make that as simple as possible and removing all of the barriers. There shouldn't be something technically they're waiting for you to do. This should be something where they're able to onboard themselves and walk themselves through the process. So both sides of this, I think, work really well. And it's something SaaS providers need to keep in mind. If you go down this path of different deployment models, you're going to have slightly different onboarding stories as well, while keeping the code base singular, which is always an interesting challenge.
Yeah, and I think that brings me to my next question, which is how do you work with that, Mike? How do you roll out new features to customers? How do you make updates to your SaaS product?
Yeah, so we keep a single code base and make heavy use of feature flags. We set up this fairly early rule early on, where a mistake that we've seen a lot of SaaS providers make is if they're providing infrastructure for people, you'll often get the request like, hey, can I customize this? Or, can I tweak this little setting, so it's perfect for me. And it's very tempting just to shell into the data plane and make that change for them. But then it's not tracked. It's not reproducible. The person who did it's on vacation, a pod goes away, you bring it back and that setting's gone. So we've put a lot of effort into having the state and everything that people could want to customize available to employees of PlanetScale in the admin dashboard. So we actually have a, like it's kind of, I can give like a hint. I can't show it, but I can give it like a hint of what it looks like. So you won't see this when using the product yourself, but staff, we actually have this staff bar. And we've found this so valuable for testing and debugging things. And these links here, if I were to click them, bring us to our backend admin dashboard. And that's where the options, like the really detailed options are. So say like we have an important customer who really needs this one MySQL flag flipped. Well, it's, in our opinion, that's not a thing that database admins should have to worry about. It's really our job. But if we think this is good for you and we're going to do it, we have this admin dashboard where we can tweak all of the infinite different settings. And then what that does is it syncs with the data plane. In the way that we roll out features, so we can do that, like we can make modifications to a single customer's database. Heavy use of feature flags. So anything that we deploy to our application, generally we do not release it to public right away. So we'll do what we call a staff ship, where every employee at PlanetScale will have access to it. And like they see the UI, like we'll be playing with a feature for months before it's really released. And then we have these rollout tools where we can go, I want 50% of users to get this. I want free plan only to get this. I want team plan only to get this. And it lets us really safely roll out different changes to very targeted subsets of customers, and which really leads us to a lot of confidence when you're turning something on for a lot of people.
Yeah, and this really, I mean, in terms of foundational beliefs and tenets of what makes SaaS, this concept of a single code base and not having branches or some other derivation for specific tenants is really foundational to having a successful SaaS product. The moment you make that decision and say, okay, we're going to support this one customer as a separate branch in our code or some other variation, it just leads you down to a dark path where growth becomes more challenging. You spend all of your time supporting these individual customers rather than providing broad value for a whole tier of customers or your whole application. And really, if you don't have that single code base, if you find yourself diverting from that, you really have to step back and think about what you're doing and how you're doing it. And feature flags are probably the best answer I'm aware of in terms of making sure that stays true.
Huge fan of feature flags here. So great to hear that. All right, so we are quickly approaching top of the hour, so time to wrap up. I just want to ask you a quick question first, Mike. When we saw the architecture diagram, there was this big Kubernetes icon in the middle of it. So just to make that clear, you're running this entirely on Kubernetes, right?
Yes. So the control plane will say, hey, this is what needs to exist. And then in the data plane, we're running Kubernetes and it makes it real. And we have this other sort of interesting process where every few minutes, we're actually telling the data plane and we're checking, hey, is this database still there? Does it still have X pods? So that it's self-healing, right? If you lost a pod for some reason, we're constantly checking, hey, bring that back up if it's not there. And that really avoids having someone on staff have to do that manually. So our system is just always taking care of that for us.
That's great. So if you watched previous episodes on this show, we've showed reference architectures using Kubernetes, and well, now we have a great example of large-scale customer actually using Kubernetes for this type of application as well. And I know, Bill, you're going to say that a lot of customers are using it. So,
as you know, interestingly, I will hear people say, "Oh, you can't run workloads like a database on Kubernetes," and I think companies like PlanAScale are increasingly proving that that's not true. You really can successfully run persistent workloads on Kubernetes. It's just a question of managing them and making sure that they scale properly and managing the health of those, just like any other application. So we do see this pattern for DB as a service providers for sure.
So Mike, we have 1 minute to go. Any final call to actions for our viewers?
Yeah, if you haven't tried out PlanetScale, I'd love for you to go to PlanetScale.com, visit the AWS marketplace, sign up and give it a try. Like any feedback you have around that sort of deployment flow, we'd love to hear from you. And you can spin up a database in about 10 seconds. So why not give it a chance?
Let's do it. All right. So thank you very much, Mike and Bill, for joining us this week. I know it's early for you, so you have a long day ahead of you, but thank you very much. And thanks to all the viewers. This was the final episode of this season of Building SaaS on AWS, but we will, of course, be back after the summer. Thank you all.
All right. Thanks, everybody.
Thank you.